Hi everyone, this video is going to address basic math and arithmetic, mainly dealing with adding, subtracting, multiplying, and dividing fractions. While this is a skill that is a basic skill, it also has a lot of rules and can be difficult. And I also know that many of you are used to working exclusively with the calculator. So some of these rules may have been forgotten, which is okay as long as we practice. So the main thing that we need to remember when we're adding and subtracting fractions, that we can't add or subtract fractions unless they have the same denominator. So we're going to have to do some conversion there to make that work. In addition, when multiplying, we usually just multiply straight across, and we do something called cross-reducing, which helps us out. When we divide fractions, we're going to keep the first fraction the same, and we're going to multiply that by the reciprocal or the flip of the second fraction. So hopefully these rules ring a bell, and you'll see them in action. So hopefully they start to make more sense as you watch this video. So we're going to start with number one. Number one's an addition problem. It says to add 4/5 plus 7/3. So the first thing I'm going to recognize is that 5 and 3 are not the same denominator. So because of that, I need to find a number that goes into that 5 and 3 both go into evenly. In other words, we're going to find the least common multiple of 5 and 3. Now in this case, that's going to end up being 15. So what I need to do here is I need to change this problem into two fractions that are going to be equivalent fractions to the original problem, but now they're going to have a denominator of 15. So if I look here at the first one, to change from 5 to 15, I need to multiply by 3. So I must also multiply the top by 3. So 4 times 3 on top is going to give me 12. And I'm going to do the same thing with the second fraction. I had a 3 in the denominator. I want to make it 15, so I need to multiply by 5, which means I multiply the top by 5. That gives me 35. Now, because the denominators are the same, I can keep the denominator and add the tops. So I can add 12 plus 35, which gives me 47. At this point, this is an improper fraction. Some of you might like a decimal better, but I'm okay just keeping it like this and circling that as our final answer. Number two is very similar at subtraction, so the rules still apply. We're just going to have to subtract this time instead of add. So I need to find a common denominator between 8 and 6. That's the least common multiple of 8 and 6. It might be tempting to say 48 because 8 times 6 is 48, but there's a number that's smaller than that, and that number is 24. So 24 is divisible by 8. It's also divisible by 6. It's the smallest number that's divisible by both of those numbers, which is why it's the least common denominator. So we change these into 24s. I take 8 times 3 to get 24, so I must take the top times 3 to get the top, which gives me 15. Here I took 6 times 4 to get 24, so I must multiply the 5 on top by 4. So when I do that, I get 20. And then all I need to do is take 15 minus 20, which gives me negative 5, and I keep the 24 on the bottom. So that's adding and subtracting. If you look at number 3, we're doing multiplication. Multiplication, we're going to multiply straight across. So I'll just show you one way to do this, and then we can go from there. But if I multiply straight across here, I can take 8 times 10 times 3. So that's 80 times 3, which gives me 240. Can multiply on the bottom, I get oh, sorry, I'm looking at the wrong one. Yeah, that gives me 240. If I look at the bottom, I also do the same thing. 5 times 12 is 60, times 4 is also 240. When I divide those out, I end up getting 1. Another way that you might do this is to cross-reduce. So that means take factors out of this to make them simpler fractions. And then that will give me an easier answer of 1. But sometimes that confuses students. So if you're confused, you can just multiply straight across the top on the numerator and straight across the top on the denominator. And then the last step is to divide or simplify those two to make your final answer. Number 4 here we have division. That's what the middle fraction bar means. So this means I'm going to take 5/8 divided by 3/4. Really what this is asking me to do is take 5/8 times the reciprocal of 3/4, or 4 over 3. So all we need to do is flip the second fraction, or the bottom fraction, and then multiply straight across like we did in number 3. So we can take 5 times 4 and get 20. We can take 8 times 3 and get 24. Now we can reduce this to 5 over 6 because 4 goes into both 24 and 20. So I divide both of them by 4 to get 5/6, which is my simplified fraction. We want to write all of our answers as simple as possible, or lowest terms. 5 looks a little more complicated, and it is. We're going to treat the numerator and the denominator separately as two separate problems. So the first thing I'm going to do is try to find a common denominator on the top and then add those two fractions. Then I'm going to find a common denominator on the bottom and subtract those two fractions. And then I'm going to divide my two answers to get my final answer. So on top I have 4/9 plus 1/4. All I need to do is figure out the least common multiple of 9 and 4, which ends up being 36. So I'm going to convert both of these to denominators of 36 like I did in number 1 or number 2. Now I need to multiply, so 9 times 4 gave me 36. So 4 times 4 will give me 16 for the numerator. 4 times 9 gave me 36, so 1 times 9 has to give me the numerator. Now I can combine these two things together now by adding. 16 plus 9 gives me 25. I keep the 36. Now I've just done the top part only. I want to now work on doing the bottom part. So the bottom part of the denominator here is 1/3, but we need to convert that to a common denominator with the 6. So the common denominator of 3 and 6 is actually just going to be 6 because 3 goes into 6. So I only need to convert the first fraction because the second fraction already has a denominator of 6. Now when I convert the first fraction, I can take 3 times 2 to get 6, so I must take 1 times 2 to get 2 on top. And now I just take 2 minus 5 and get -3 and keep the over 6. Now this becomes a division problem much like number 4, so I'm going to do the same thing. I keep the top part, which is 25 over 36, and then I multiply by the reciprocal of the bottom fraction. So instead of having 3 over 6, I have 6 over 3. Now when I do this, I can multiply straight across, but this problem is actually easier to approach by saying that 6 can go into 36. So what I'm going to do here is do the cross-reduce method. Now if you don't like this, you could still multiply straight across on top, straight across on the bottom, and then divide. But to show you how much work this could save you, I'm going to show you the cross-reduce method. Because 6 goes into 36, I can cross out 6, and I can cross out the 36, and say that 6 goes into 36 6 times. So now I've made the bottom way easier than it was before. And now this top where the -6 was is just a 1. So now I can multiply across the top, and I have 25 times 1, which gives me -25 because the negative's still there. On the bottom, instead of having 36 times 3, I have 6 times 3, which gives me 18, which is much easier to deal with, and that will end up being my final answer. So here, what you're noticing is that if you can reduce the fractions before you multiply, it will save you the step of reducing them after you multiply. It will also allow you to do simpler multiplications instead of multiplying 36 times 3 in this problem. We only multiplied 6 times 3. Which is far easier to do without a calculator. If you look at number 6, this is just an addition problem, so we need a common denominator between 8 and 20. Without too much work, we'll realize that that number is 40, so we're going to convert these fractions. 8 goes into 45 times, so I multiply the top by 5, and I get 5 over 40. 20 goes into 40 twice, so we multiply the 3 by 2, and we get 6. We add them together, 5 plus 6 is 11, keep the 40 in the denominator. We're finished. Number 7, you see here we have mixed numbers. We have 7 2/3 minus 4 5/8. First thing you need to do is convert the mixed numbers into improper fractions. And the way that we do that is we take the big number here, 7, times the denominator, 3. That gives me 21. Then we add it to this 2, gives me 23. So we get 23, and we keep the 3 that was originally in the denominator. So we can say that 7 2/3 is the same thing as 23 over 3. We can do the same thing here with this problem. 4 times 8 is 32, plus 5 is 37, so we have minus 37 over 8. Now you'll see this is a subtraction problem. We need to find a common denominator. That common denominator between 8 and 3 is going to be 24. So what we're going to do here is we're going to convert both of these fractions into 24 as the denominator. Here what we do is we take 3 times 8 to get 24, so I have to take 23 times 8, which ends up being 184. And I take 37, or 8 times 3 gave me 24, so I take 37 times 3, and I get 111. Now what I do is I subtract the top, so 184 minus 111 ends up being 73. I keep the denominator of 24, which ends up being my final answer. If you wanted to write this in another way, this is the same thing as 3 and 1/24, which would leave the answer as a mixed number, but I'm okay with the improper fraction. In fact, improper fractions end up being very useful in pre-calculus. If you look at 8, we're now combining operations, so we have an addition problem, but we also have a multiplication problem. Because order of operations is PEMDAS, it tells me to do multiplication before addition. So what I'm going to do is I'm going to multiply 15 over 2 times 3 over 5 before I deal with the 1/2. And I'm going to do the cross-reduce method. We notice here that 5 goes into 15 3 times. So I make the 15 a 3 and the 5 a 1. And now I keep the original 1/2, I keep the plus, and now I multiply these across. So 3 times 3 gives me 9, 2 times 1 gives me 2. Now, lucky for me, I have a problem with the same denominator, 2's, so I just add the tops and I get 10 over 2, which I can reduce to just 5, because 10 divided by 2 is 5. Okay, moving on, we're going to look at number 9. Number 9 looks annoying because the fact that we have a square root in the denominator. So one of the things that we're going to do here is I'm going to go ahead and get rid of that square root before I do anything else. So to get rid of that square root, I'm allowed to multiply that square root by the square root of 3 on top and the square root of 3 on the bottom. That's called rationalizing the denominator. It will get rid of the square root in the denominator and make my life simpler. So when I do that, I keep the first expression the same, 5 times the square root of 3 over 3. And then I multiply straight across, so 2 times the square root of 3 I just leave as that. And then the square root of 3 times itself is just the square root of 9, which ends up being 3. Now I have the common denominator of 3, so I can just add the tops. It's 5 times the square root of 3 plus 2 times the square root of 3. They are like terms, so I can combine the 5 and the 2 and add them and get 7. Keep the square root of 3 just like it was a variable like x, and then I still have the 3 in the denominator. That's my final answer to this problem. That one's a little bit confusing. It combines multiple skills from geometry, where you had to learn to rationalize the denominator, as well as some advanced algebra when you're adding the radicals together or the square roots together. If you look at number 10, we go from harder in number 9 to a little bit easier. It's a division problem, so we do the same thing we did earlier, where we keep the first fraction the same. We change division to multiplication. We flip the second fraction to get the reciprocal. Don't forget about the negative here. And then what we can do is we can multiply straight across if you want. We could do cross-reduce method. I'll multiply straight across since I did cross-reduce the last couple of times. So I multiply 2 times negative 10 and get negative 20. I get 5 times 7, which gives me 35. I then reduce that fraction because 5 goes into each of these, so I divide by 5 and I get negative 4 over 7 as my final solution. Now we're going to move on to the last couple. They do get a little bit harder, and then we'll be done with this video. Number 11, you see the pi, you might immediately freak out. Just treat it as a variable, don't worry about it. We still have to do the same process, get a common denominator between 4 and 3. That ends up being 12, right? So we convert both of these to 12. Whoops, sorry about that. We convert both of these to 12. When I do that, I realize that 4 times 3 gave me 12, so 3 pi times 3 is just going to give me 9 pi. We just multiply the numbers and keep the pi. Here I went 3 times 4 gave me 12, so 2 pi times 4, that gives me 8 pi. Now all I do is the same thing. I add 9 pi plus 8 pi, which just ends up being 17 pi, and then the denominator stays 12, and this problem is now finished. So basically when you have like a square root of 3 like we had a previous problem, or pi, treat it as if it's a variable and it's like terms, so you can just add them together like normal. So if we look at 12, we need to find a common denominator here. So I have 8 and 24, so the common denominator is going to be 24 because 8 goes into 24 evenly. So we go ahead and do that. 8 times 3 gives me 24, so 12 times 3 is the numerator, so that's 36. Denominator here stays the same here. Our numerator stays the same because it's the same fraction. We take 36 minus 12 and we get 24. Keep the denominator, which is 24. That gives me 1 for the final answer. So actually it looks a little harder than this one was. If you look at 13, we're going to have a similar thing happening. Looks difficult, but ends up being easy. 3/4 times 4/3. If we realize 3 goes into 3, so they cancel out. 4 goes into 4, so they cancel out. So that just leaves me with 1 minus 5/19 divided by 5/19 ends up being just 1 because I'm taking a number and dividing it by itself. So we have 1 minus 1, which gives me 0. Now also, you shouldn't subtract until the end, which is what I did because of order of operations. It says do multiplication, it says do division before you do addition and subtraction. So that's why we're organizing this problem in this way to get 0 as the final answer. Number 15, similar here, 2/3 squared. You just square the top and square the bottom. So the top means 2 times 2, which is 4. Bottom means 3 times 3, which is 9. Then we take the square root of the top and the square root of the bottom. So the square root of 25 is 5. Square root of 81 is 9. We add these together now. They have the same denominator already. So we take 4 plus 5 on top and we get 9. Keep the 9 on the bottom. And that equals 1 when we simplify that because 9 divided by 9 is 1. Last problem. We're just going to distribute the 3/5 to both terms. This is an x. It's a variable. So that's not going to... my final answer here is not going to be just a number. It's going to have a variable in it. So we multiply here. The first thing we do is 3/5 times 5/6. So when I do that, we can write it out. 3/5 times 5/6x plus 3/5 times my 1/3 that's left over from here. Now you can notice that we have some cross reducing here because this 5 and this 5 are going to cancel out, leaving a 1 and a 1. Which is going to leave a 3, and then this 3 goes in to this 6 twice, so that's going to leave me here with a 1/2 x. And then here you notice that 3 and 3 cancel out and leave a 1 and a 1, which is going to leave me with a 1 on top and a 5 on the bottom, so I'm going to have plus my 1/5. And this problem is finished because these are not like terms. I can't combine them. So once again, it's really important to remember the rules. Here's the answers to all 16. I hope that helps. If you're lost, just come see me. We'll get this squared away during the first week of school, and you'll be good to go for the rest of the year.